All right, today we're working on this worksheet called Intriguing Inverses. Okay? Now, before we start on the worksheet, I have a question for you, and it's a question we answered yesterday. I'm going to also ask you tomorrow, and I'm also going to ask you the next day. I'm going to say to you, how do you find the inverse of a function? And you're going to answer all together by saying, switch x and y. Right? So let's practice. How do you find the inverse of a function?
Switch x and y.
How do you find the inverse of a function?
Switch the x and y.
How do you find the inverse of a function?
Switch the x and y.
But what if you have a table?
Switch the x and y.
What if you have a graph?
Switch the x and y.
What if you have an equation?
Switch the x and y.
Everybody get the point?
Switch the x
Thank
and
you.
y.
Thank you. Okay. So, first thing we have to do on this worksheet today, it says list 5 ordered pairs from points on this function graphed below. So, how many points are on this function right here? A lot, right? An infinite amount of points. Are there like a best points to choose?
Yes.
What would be an example of one that's a best point to choose?
One that's exactly like on.
So like negative 1, 0? That point right there?
Yes.
What would be another point? 0, 5?
And negative.
Negative 3, 4.
Negative 3, 4.
And then
You could do
negative 5,
3.
0.
Negative 3. Negative 6, 5. It's negative 3, 4.
Negative 5.
Negative 3, 4 is a great one.
Negative 6, 5.
Negative 6, 5.
Negative 5, 0.
Negative 5, 0. Okay? Now, I said to you, are there some best points to choose? And you said yes, and chose these 5. But nobody told me why you thought those were the best points.
Because they actually lie on.
It's actually an intersection of a point, right? I don't really want to choose this one because this one is like negative 4 and something and positive 4 and something.
Wait, could we use 2 more?
We could choose 2 more, but we don't have any more blanks.
Oh, yeah.
Okay? Yeah, there's a point right here that it passes through and a point right here that it passes through. So those would be possible, right? But why are these the 5 best points to choose? It gives us the shape, doesn't it? Okay, absolutely. It gives us the shape. So, like this one, especially these 3 right here, are actually where it's changing direction, right? The function is changing direction right here, right there, and right here. Okay? So, use these points to name 5 ordered pairs that would be on the inverse relation of the function. How do we do that?
Switch the x and the y.
The x and the y. So 0, negative 1, 5, 0, 4, negative 3, 5, negative 6, and 0, negative 5. So with a different color, I'm going to graph those. If you need to use a different color, please do. If it doesn't matter to you, okay. Okay, so 0, negative 1. 1, 2, 3, 4. 5, 0. 4, negative 3. 5, negative 6. Is that right? 1, 2, 5. Yep, negative 6. And 0. 1, 2, 3, 4, 5. Negative 5. So I had some crazy kids earlier that were like they were going here, 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 here. Is that what it needs to look like?
No.
What does it need to look like?
It needs to look like this.
Oh, there was also this crazy kid earlier that was like, look, it looks like an upside down M. And her seat partner was like, you mean a W? And that made me laugh. It was really fun. Okay. How do I connect these? Does it matter what order I connect them in?
No.
It doesn't?
Yes.
It kind of does. In fact, it really does, right? Because what's supposed to happen is this shape is supposed to do what?
Just a little.
A little reflection across? Across what? What's it reflecting across? We did work on that yesterday. Yeah, the line y equals x, right? It reflects across the line y equals x. So I need to connect these two. This is a little roundish. And then I need to connect these two, right?
Why is yours always perfect?
Because I'm amazing. That's why mine's as good as it is.
Not true. Take it back.
No, it's fine. He just failed. Don't worry about it. Okay. Go ahead and please draw in the line y equals x here. That really helps us see that if I folded this paper, wouldn't they be right on top of each other if I held them up to the light? They would, right? Okay. Is the inverse relation also a function? Is this a function?
No.
Yeah, I'm hearing yes and I'm hearing no.
No.
One
It's
of
no.
those is correct.
It's no.
Why is it no?
Guys got repeating x values.
No.
If it fails the vertical.
They don't pass the vertical line.
Both of those are the same kind of answer, right? So you don't have to have both of them. I wrote both of them because I heard both of them. Okay? But they are both correct. X is repeat and it fails the vertical line test. Okay? We're talking about the function y equals 1 over x now. If the equation is y equals 1 over x, can we fill in this table? I know it tells me to use a calculator. I'm ignoring that. I'm smarter than the calculator. So are you. If x is negative 2, what's 1 over negative 2? Negative 1/2. If x is negative 1, what's 1 over negative 1? Negative 1. Here's where it gets a little tricky, but we're not going to let it trick us. Okay? What is 1 over negative 0.5? 1 over negative 0.5. Are we allowed to have decimals in the denominator of a fraction? Or even, well, I guess we can have them in the numerator, but we don't even like that, do we? Okay? So I'm going to write it like this for a second because it's a little bit easier to see.
That's a fraction in a fraction.
That is a fraction in a fraction. We don't like that. Fraction police are coming. We got to get rid of it.
Hurry.
Some of you guys are more used to that than others, right? Okay. So, how do I get this out of the denominator? Multiply by the reciprocal, right? Okay. What's the reciprocal of 1/2? 2 over 1. If I just multiply the denominator of the fraction by 2, haven't I changed the value of the fraction? Yes, so I also have to multiply the numerator of the fraction by 2. Now, what is the value of that fraction right there? 2 over 1 divided by 2 over 1?
Equals 1 whole.
It equals 1, right? This is what's called a clever 1. We're finding a clever way to multiply something by 1 that's going to help us make it look different. Okay? It's called a clever 1. Because all we're doing is multiplying by 1, right? I can multiply anything by 1 and not change its value. Okay?
Right.
So what happens in the denominator right here? What's 1 times 2? What's 2 times 1? So what's 2 divided by 2? 1. That's what I needed. I needed a 1 in the denominator, right? What's 1 times 2? What's 1 times 1?
1.
So I end up with 2 over 1 over 1, which is really just 2 over 1, which is really just what?
1.
2. What did we forget? The negative sign, right? We cannot forget that. This was a negative 1/2, so that's got to come along here, and that's going to come along here. So, in this case, when x equals negative 0.5, what does y equal? Negative 2. When x equals negative 0.4, we're going to do the same kind of thing, right? 0.4 is really the same as 2/5, right? 4/10 is 4 over 10. So if I multiply by the reciprocal, which is 5 over 2, that's going to give me 5 over 2. And remember, I did start with a negative, so I'm going to end up with a negative. What is negative 5 halves the same as? Negative 2.5, right?
Goes in half.
Negative 2.5.
There's a little pattern here.
There is a pattern here. Guess what the next one's going to be?
3. No, it's going to be 2.
It's going to be positive 2.5, right? What's this one going to be?
1,
2,
2 and 1 half.
1,
yeah.
and 1 half.
1. No, it's going to be 1 and then 1. That's what you said.
So what does the inverse table look like? I'm sorry, what did you say? It's flipped, right? Now, there was a little confusion earlier. I want to make this very clear. I'm not encouraging you to flip off the table, right? That's not nice. We're going to point with our pointer finger and not another finger, okay? We're wanting to take x and y and flip it over here, not flip it off, okay? So negative 1 half, negative 2, negative 1, negative 1, negative 2, negative 0.5, negative 2.5, negative 0.4, 2.5, 0.4, 2.5, 1, 1, and 1 half, and 2. Okay? Now, what it asks us to do is use these points to name ordered pairs that would be on the inverse relation of the function. Now we need to graph the inverse. Plot these points on this graph. Do it. Plot those points on that graph. Do it quieter. Gracias. Plot these points on this graph, the inverse points. Negative half, negative 2, negative 1, negative 1, negative 2, negative a half, negative 2 and a half, negative a fourth. Wait, I think mine's broken. Yours is broken too? Okay, why do you think it's broken?
Well, that's weird because it's minus.
Because what I asked you to graph was these, right? Where are they ending up?
They're right on the same thing.
Right on the same thing. Is that allowed? Have I done something wrong? I have. What have I done wrong? Everything? So I'm about to do this wrong too. Get out. Just teasing. 2.5, 0.4, 2.5, 1, 1, and a half, 2. What do you notice is special about the inverse relation of this function? You saw me plot the inverse points, right? But where did they end up? On the same function. It's its own inverse. It's its own inverse. Is that allowed? Yeah, absolutely. It's its own inverse. Not universe, not universe, inverse. There's a slight difference. Slightly. Okay? Guys, but think about this. If I put in my line y equals x, and I folded it, what would happen?
They're base same.
Wouldn't they end up right on top of each other anyways?
Yes.
That's why it's its own inverse. Okay? Alright, so this is what you're doing for the rest of the period. You've got to fill out the inside of this. Notice for me, please, that the graphs on this page are the parent functions. This is what we've been talking about since the beginning of school. There are no transformations on this parent functions. That was last unit. We've already covered that. We're trying to figure out the inverses. So find some points from this graph. Put them on the table. Flip the table. Like flip x and y. Plot the new points. And then please compare the graphs from the parent and of its inverse.
Just a little flip.
Okay? Now,
Yeah.
the thing that really concerns me a lot today is the fact that a lot of people want to put that there's a rotation. Okay? Does this look like there's a rotation? Yes, it does. I get that. Okay? But you have to remember we're starting here and going here. Right? We're not just like turning it this way. I proved that yesterday with this one, right? We can't just slide this one around and have it be on top of the original or the inverse, can we? Okay? It has to be from here to rotate to here. Excuse me, to reflect from there, not a rotation. It is a reflection. Okay? So on these where you're comparing it, please don't put it's a rotation. Because while it may look like it's a rotation, how do you find the inverse?
Flip the X and Y.
Flip the X and Y, right? A lot of you showed me with your hands. Once again, appropriate hand motion. That's good. Okay, but I need you to enunciate the fact that we're flipping X and Y. We're switching our X and Y. Right? Any questions about this? Okay, you have until the end of the period to get this done. Please don't forget to do your flip video tonight. Okay? Mark, get set, go.